Okay, let's talk a little bit about work, energy, and power. Now, before we start any of this, we have to talk about the law of conservation of energy. That's the main theme in this entire unit. It's talking about energy. You have to talk about the law of conservation of energy. Basically, what it states is that energy is always constant. It is never created or destroyed. It's only transferred from one form to another. Okay. Basically, what this means is that the energy that we start with is the energy that we finish with. Okay. Now we don't transfer all of the energy. We'll talk about efficiency at the very end of this, but basically what happens is we lose some of the energy, sometimes to friction and sometimes to thermal energy. But basically, we don't ever get rid of any energy. It's only transferred. Now, the big equations that we have here, we see that we have work over here. Work equals force times distance. Now, work, when we use the term work, the one thing that we want to think of is the only time that work is ever done in physics is when the force is applied perpendicular to the direction that the object is traveling, the object is being moved. Okay, that's the only time that work's being applied. One of the classical problems that they always say is they give you a ramp that's 5 meters tall, and they say that you push the box up a ramp, and we're going to say that this is 7 meters. Okay, so you push it up a ramp that's 7 meters long this way. Okay, but it only goes up this distance. Okay, and it says what work is being done to this. Well, the only real work that's being done to it is the one that's the force that's being applied parallel to it. Okay, so this is the distance that it's traveled, so it's only the work that's pushing it up, basically. And they love to put this problem in there just so that you can make sure that you know when work is actually being done. Okay, it has to be parallel. Okay, now the other equation that we have here is power. And power is the rate at which we do work. Okay, so power is work divided by time. Okay, time is in seconds. Work is obviously always its energy, so therefore it's in joules. And so power has its unit of watts. Big problem that people like to do here is they see the unit of watts and they go, oh, that's work, and they like to plug it in there. No, watts is power. Okay, it's not work. Watts is power. Work is always in joules. Okay, remember, coming back over here, make sure we're paying attention to these units over here. Remember that force is always in newtons, and our distance is always in standard units of meters.